Problem 5, finding the greatest possible percent error. The diagram below shows the dimensions of a gift box to the nearest inch. What is the greatest possible percent error in calculating the volume of the gift box? The measured volume, 5 times 6 times 12. Volume is length times width times height, so 360 cubic inches. The minimum volume, well, perhaps this 12 inches, since we were rounding to the nearest whole inch, was actually 11.5. That's the smallest possible size it could actually be and have us still arrive at a measurement of 12. So 11.5. We do something similar here with 6, with the minimum being 5.5, 5 and 4.5, but we multiply all three of those together and we get 284.625. So that's the minimum possible actual volume. And then we do something really similar to find the maximum possible actual volume, 12.5 times 6.5 times 5.5. And we arrive at 446.875 cubic inches. So now we're going to find the differences. The minimum volume minus the measured volume. So our minimum possible minus the actual measured volume leaves us with 75.375. We do something similar here with the maximum volume minus the measured volume, and we arrive at 86.875. Now we needed to complete both of these in order to find the one that's going to give us the greatest possible percent error. And if we just use the minimum, we wouldn't be finding the greatest possible percent error. We would be finding one of the possible percent errors if all of our lengths had actually been smaller than measured, the minimum possible. But we know that 86.875 is greater than 75.375, so that's the value we're going to use when we divide by the measured volume and find a decimal answer of about 0.24 or 24%. So our answer is a complete sentence. The greatest possible percent error in volume based on measurements to the nearest inch is about 24%. And your turn. Reasoning. If a gift box's dimensions were measured to the nearest half inch instead of the nearest inch, how would the greatest possible error be affected?